So now we'll move on to our final speaker, who is Damien Barrett. Damien is qualified from UCD here in Dublin also, and Damien currently works in our Sligo Regional Veterinary Laboratory, and he's going to talk to us about prevalence and distribution of exposure to Schmallenberg virus in Irish cattle.
Okay, thank you very much, Sally. As Sally says, I'm just going to run through some serological and pathological studies that we carried out on Schmallenberg. As most of you are aware, Schmallenberg was first emerged in Europe in 2011, and clinically it's associated with congenital malformation of the musculoskeletal and the central nervous systems of ruminants. And there's been extensive spread throughout Western Europe, and it's a wind-borne disease carried by the Culocoides species. The first case of Schmallenberg virus was diagnosed in Ireland, in Cork in the south, in October 2012. At that stage, we anticipated that there was going to be quite an amount of spread in 2013, and the objectives of this study were to determine the seroprevalence and distribution of exposure to Schmallenberg virus from November 2012 to November 2013. On the pathological side of this, samples of brain were collected from malformed bovine and ovine fetuses submitted for routine post-mortem examination. We encouraged farmers to, if they had a case of a malformed fetus, in those cases the laboratory fee was waived, and there was a campaign, information campaign in the farming press. Those samples of brain were tested for Schmallenberg using real-time PCR, and we had 3 serological surveys were carried out on bovine sera, and these were submitted on samples that were submitted for routine brucella testing. And we carried out a spatial analysis of both data sets. And just to give you an idea here, these cases here in yellow, these were cases of confirmed pathological cases. Here in red, we have confirmed serological cases, and here we have in green cases that were herds that were serologically negative from the serological survey. In November 2012, the first survey was carried out, and basically we found seroconversion was more or less confined to the southeast of the country. And as in 2013, we were anticipating that there would be far greater spread up through the country, but it never materialised. And the herd prevalences in each of those surveys was about 500 herds, and they were statistically chosen per county. There was a herd level seroprevalence of 53, 51 and 53% from those surveys, and animal level seroprevalences of 36, 35 and 33 respectively, so effectively no change. The herd level seroprevalences in counties ranged from 0 in the northwest to almost 100%, to indeed 100% in the southeast. Then what we did was we decided to compare the pathological herd incidence and the serological herd prevalence by this spatial analysis that was carried out by Guy McGrath in University College Dublin in Severa. And basically the aim of the pathological surveillance is to detect cases. And the aim of the serological surveillance is to quantify the extent of exposure. Now, while these two strategies do complement each other, they're not directly comparable, but it was gratifying to find that the pathological-based surveillance programme did correctly identify the parts of the country that were exposed. So what we can see is that the south and the southeast were initially exposed in 2012, and there was no evidence of further spread. Now that's an unusual finding in the context of a lot of European countries. And I suppose why we believe that to be the case was that the time of the initial incursion was considered to have been around August 2012, which is relatively late in the vector season. If the incursion had occurred earlier in the vector season, it's likely that there would have been greater spread within the country. What this does tell us is that there was, where there is seroconversion in the south and the southeast, in those areas, the younger age cohorts which have been born since that incursion are now immunologically naive, and if the disease was to re-emerge, would be susceptible. We also found that in the areas on the margins of the epidemic, there was partial conversion within the cattle population, partial herd conversion. So again, these areas, if there was a re-emergence, would be at greater risk. So with that, Madam Chairwoman, I'll take questions.
So does it... So do we have questions for Damien, please?
Claude Hammers from France. If you look in continental Europe, you will see that there are a lot of serological evidences that the virus SBV continues to circulate.
Yes.
Do you have any idea of the seroprevalence in young stock in Ireland in 2015 or 2016?
Yeah. I have a colleague here, Anya Collins, that's carrying out studies on that at the moment, and there has been no seroconversion within the young stock, particularly, and that surveillance is particularly targeted on the south, and where would be the area which would be at greatest risk. So I don't know, does Anya want to add anything to that? But at the moment, within our young stock, there's no evidence of exposure in Ireland since. You see, Dr. Carpenter's talk there about on the analysis of Met data. Our colleague here, I have a colleague here, I think I can see him there in the audience, Ronan O'Neill, that's involved with these studies, and there requires very specific weather conditions that occur maybe about 4 times a year. For the wind has to be coming in the right directions, and there has to be midges in that wind, and they have to be carrying virus, and then they have to run into cattle here in Ireland, and it can be difficult enough for all those conditions to occur together.
Hi Damien, thanks very much for that. I'm Anya Collins, and I'm doing some work on Schmallenberg virus in Ireland also. In the south of Ireland, we have 26 herds which we've monitored for Schmallenberg virus circulation in the years after SBV first arrived in Europe. And in 2014, we found very, very limited evidence of SBV circulation. It was estimated to be less than 1%, it was 0.6%. And in the young stock, we blood sampled over 1,500 young stock in 26 herds in Munster. And there was 9 animals in the first year that showed evidence of antibodies, but when we followed them up in winter 2015, they were all seronegative. So we've put down those 9 seropositive animals to persistence of maternal antibodies. But other than that, there's no evidence of SBV circulation in dairy cattle herds. We've also collected coulicoides in Munster also, so in the south of Ireland, and we've tested those for Schmallenberg virus. We took the samples to Poland in Dr. Magdalena Larska's lab there, and we found no evidence of SBV in the coulicoides either. So at this time, there's no major evidence of SBV circulation in Ireland. But if you want to learn more, there's a couple of posters upstairs. Thank you.
Magdalena Larska from Poland, and I have a question. Why the virus did not was just limited to the south of the country. Why in the same activity of coulicoides did not go further up?
Yeah. This relates to the time of year in which it was introduced, which will be around the middle of August 2012. And it worked. The weather in 2012 here in Ireland was particularly wet, and it was probably a little bit colder than usual. And our hypothesis is that it worked so far up the country, and at that stage temperatures were cooler, and it didn't get any farther than that, than where exposure has been documented. If it was introduced, say, in May, and we had it had the opportunity of a warm summer, I've no doubt that it would have moved a lot farther, or it would have moved northwestwards much more.
Thank you very much. I'm just wondering if anybody has a question for Owen Ryan, the previous speaker, since we didn't have time. Nobody? Okay. Well, in which case, I would like to thank all our speakers very much for their contributions. And thank you to you as an audience for all your questions and your attention. Thank you very much.